Good evening. Hope you're having a great time at Build, one session away before we wrap Build 2019. Thank you for being here to make the world more secure. In this session, we'll explore the problem of secret management. We'll walk in the shoes of a developer to see the common practices that eventually lead to a scenario that compromises them. We'll cover some best practices and architecture that will help improve security and make their services be ready for a breach. And finally, we take this opportunity to show you some new features that we have been working on. This will bring security and usability together. I'm Kripa, Program Manager in the Azure Red team.
I'm Rich Randall, Engineering Manager on Key Vault.
To give a little more context, the Azure Red team mimics bad actors, tries to attack Azure to make it stronger and ready for real-world attacks. We live in a world of secrets. When a friend comes and shares a secret, our immediate reaction is not to post it on Facebook. Rather, we treat the secret secretly. Taking this analogy to the coding world, let's see through a few questions if this is relevant. Let's see if we are keeping secrets secret. I would love for you to raise your hands if these questions seem relevant, but I know you have done this so many times, so I'll spare another yoga exercise. But using my Jedi mind skills, I'll be able to see those of you who are thinking about this, virtually raising your hands, thinking about a scenario, a situation where you have seen credentials getting exposed. All right, and for those who are not yet convinced, those of you, I can still see you guys not virtually raising your hands, let me show you some advanced red teaming and dark magic.
No.
Looks like the dark magic is working really well. Looks like the dark magic spell veered off, and we have projection again. Okay, thank you. Okay, so coming back to the advanced red teaming, I'm in GitHub using my default account. And I'm going to the search engine or search bar and typing in a dark spell, client_secret. Oh, OK, so this is returning 1 million hits. While obviously not every hit is going to contain a credential, let's explore and let's see if we can find some. I'm going to JSON, a popular choice for storing client ID and client secrets. Oops, looks like someone's client ID and secrets are here, and a bunch more. If this is the power of a default search engine, imagine what a credential sniffer can do. A recent study conducted by North Carolina State University, over 13% of publicly available GitHub repositories finds nearly 100,000 repos having some sort of credential. It could be token, connection strings, API keys, and they also share these statistics. It just takes about 20 seconds if you are looking for the right pattern to identify a leaked key. Nearly 1,800 keys are getting exposed in GitHub in those 13% on a day-to-day basis, 90% of which are genuine, real, usable keys. The graph on the bottom left basically shows, even after 2 weeks, 81% of these keys continue to remain in the GitHub. Guess what? Bad actors love this. This gives a very strong foothold for the bad actors so that they can further infiltrate your service. The impact is solid and clear. Year over year, we are seeing a trend that basically shows increasing number of cases which are happening due to exposed credentials. Now, as the world embraces more open source, as more and more repos get exposed, this trend is going to continue if we are not deliberate and start acting on it. Fundamentally, we all agree that secrets should be in a secret management service. Only at runtime should an application access the secret, use it, and discard it. But the reality is quite different. The secrets are present everywhere. Code, email, file share, anywhere, they are secure. I mean, unsecure, obviously. So it's very important to understand why this is happening. Here are a few scenarios, though this is not comprehensive, but helps us get started into thinking why this is happening. It could be because a developer uses a quick start and then builds a prototype and pushes the same code to production. Somewhere in the Git history is that lead credential that the developer has introduced during the prototyping phase. The quick start or samples are meant for explaining a concept, not for production. But in a time crunch, the developer pushes it, and the rest is history. Another scenario could be that a developer is trying to repro a production identity issue. What he does, he simply takes the production identity secrets, puts it into a configuration file, and introduces Credential. Or it could be as simple as you are part of a very big team, and as part of the onboarding documents, you really want to make it easy. So what do? Put it in Git, put it in file share, put it in OneNote. Likely, the developers are not even aware that they are exposing credentials, or they're not really understanding the gravity of the situation. At this particular point, you must be feeling, man, secrets are a very hard problem. It's like searching those needles in a haystack. Like a strong magnet, which is an effective solution to the needle problem, here's a simple yet effective strategy to deal with your secrets. First, you need to discover secrets. You can only fix what you can find. So the first part is to make sure you're regularly looking out for these secrets. Next is managing them. Once you see that you have a credential that is exposed, you need to either eliminate it totally or start using a secret management service. And the key rule to remember here is you should really use secret management service, not replicate this secret to file shares or any other places. And finally, the hygiene part. Make sure to rotate your secrets regularly and keep auditing them. So here's our demo scenario. Jasmine is a developer working for a gaming company, Endgame. And after the recent events, their company decides to move to Azure. Now, Jasmine is tasked to create a cloud adoption rate service so that they can measure how quickly their company is adopting Azure. So here's the game plan that Jasmine puts together. Being new to Azure, she basically divides the problem into 3 parts. In the first stage, she wants to figure out the authentication part. Just authenticate to Azure, get the list of resources back. In the second stage, she wants to push the results to a database so she has point-in-time history of the usage that their team is having. And finally, she pushes this to an Azure web app that's hosted in Azure. To build this service, Jasmine is going to use Python, Flask framework, and Azure Devops pipeline. Before I jump to code, here are a few steps that Jasmine does. Jasmine goes to the Azure App Registration portal and quickly creates a new application. Azure then provisions an application ID and a secret with which Jasmine can authenticate to Azure. OK. So here's Jasmine's first take on her code. She has created a basic Flask application with 2 web pages, a home page that defines a short welcome message and a resources page. In the resources page, what she's going to do is she's going to authenticate to Azure and get a list of resources. To authenticate to Azure, like any other identity and access management system, it basically needs a client ID and a secret. Once the client ID and secret are provided or given to Azure, Azure responds back with a credential. This credential has a bearer token. This token can be submitted to any other Azure services that can validate, authorize, and authenticate the request before processing requests. OK. So let's take a look on how she implemented the resources method. First, she's getting credentials through authenticate method. Once she gets the credentials, she's going to pass the credentials to another method, get resources from Azure. That is going to give her the list of resources and resource count. Now, let's go and see how authenticate method looks like. Jasmine, like any other developer, uses config.json to put her secrets. So she has her app ID, password, and tenant ID. Then she passes these to service principal credentials. Once this method gets all the parameters, it's going to respond back with a credential from Azure. After she gets a credential, we are passing it to get resources from Azure method. Let's take a look what happens here. OK, so she's creating an instance of resource management client. Now, resource management client is an instance of Azure, basically calls Azure Resource Manager, the service that provisions new resources and can give you the list of resources that are currently there in Jasmine's subscription. OK, now I'm going to run this application locally and see if Jasmine is successful. OK, so the application is ready. I'm going to localhost, and I have my resources. I'm clicking on it. Boom. Looks like there are 223 resources. And also, please take a look at the resource ID was requested by A3 and ending with 98. This will be critical. Happy with the progress, she's basically ready to push this code to remote. I'll just add a comment. Done with stage 1, save it. Hooray. And then commit. And then I'm pushing these to my remote repository. OK, so first of all, I'm sure you guys have figured out by now that Jasmine has introduced a credential. She hard-coded it in her JSON file because she's under a time crunch, and also due to this, she's using her production identity. 2 bad practices. Now, the key aspect to understand over here is that Jasmine is not even aware that she is introducing, and that could be a risk. Now, in future, if her company decides to go open source, there is a breach that can potentially happen because there's an exposed secret. Now, the problem of secrets is for everyone. Internally, at Microsoft, we use Credential Scanner, an extension in Azure Devops that scans our source code for credentials. We are happy to bring this capability to you as an Azure Devops extension that you can find in Marketplace. This not only helps discover secrets, but also stops your builds when Credential Scanner finds one. The core of Credential Scanner engine has been deployed to various Microsoft services. Because as we have seen earlier, credentials can be present anywhere. We have pushed Jasmine code, right? So let's go back and quickly take a look what happens. OK, so we have enabled Credential Scanner on Jasmine's extension. I have these tasks that are basically created on her build pipeline, basically running Credential Scanner, analyzing the logs, and posting me results. So I'll go to the build that she has triggered. All right, so here's the Hooray build that basically we've committed. And as you see, I've configured this particular Azure Devops pipeline to trigger Credential Scanner as soon as I push something to remote. And the build failed. The Credential Scanner ran successfully and found one issue. Not only it stops the build, but tells you exactly in which file did it find credential. Looks like in config.json, in line 3, Credential Scanner found a credential that Jasmine introduced. So far, Jasmine is just aware that she has a problem. She still needs to go ahead and solve it, which basically leaves her with two choices. Either eliminate it completely or start using a secret management service. Because in this particular scenario, Jasmine is just talking with Azure. And as her dev machine is in Azure, she can use the power of managed identities. With the help of managed identities, she can completely eliminate secrets. So what are managed identities? Azure Managed Identities is a special feature in Azure that basically gives you the ability to assign an identity to your resource. What does that mean? Now, these resources, when a managed identity is given, are capable to authenticate to Azure, get these tokens that Azure wants or the Azure services want, and provide to them. Now, the other benefit of using Azure Managed Identity is that you don't have any credential that you have to take care of. Azure manages this on your behalf. Now, let's go back to Jasmine's code and see how we can use managed identities. But before that, let's basically go and take a look on how simple it is to assign a managed identity to any resource. So this is Jasmine's dev machine in Azure. I'm going to Identity, Blade. And over here, I have toggled on System Assigned Identity to On. And that provisioned an object ID. That's it. All of a sudden, this virtual machine now has a managed identity and can start authenticating to Azure. Let's go back to Jasmine's code. I'm going to the authenticate method, and then I'll remove the reference of using the config.json. We no longer need this. Next, what I'm going to do is, instead of calling the service principal credential that uses the application's identity, I'm simply going to say MSI authentication. That's it. Not only I simplified my code, I'm not using any credentials in this scenario. Before I run this, here's the resource ID that earlier we have seen. Now I'm going to run this locally. All right, so the application is up and running. I'll go ahead and create another tab so we retain the previous requested ID. I click on resources, and I see 41. So now this is another requester that basically, without any credentials, was able to talk to Azure, get that token, and give this token to ARM, the resource manager client that processed the request. OK, so happy with her progress so far, Jasmine moves to the next stage. And in this particular stage, she decides to push the resources that were obtained from Azure into a database. But here's where she hits another brick wall. Jasmine's database doesn't support Azure AD authentication. That basically means that now she has a scenario where she has a connection string, or basically a secret, that she cannot eliminate. Now, what does Jasmine do? She's going to leverage Azure Key Vault, the secret management service in Azure. By using Azure Key Vault, she can bootstrap with AAD authentication. Key Vault supports AAD. As a result, going back to Jasmine's scenario, the MSI first authenticates to Azure and then gets the token. Once the token is obtained, it's going to give to Key Vault. Key Vault will validate the token because it understands Azure AD, and then basically validates if this requester, the application, the MSI, the managed identity here, has right access or the correct access to get the secret from Key Vault. So now let's basically take a look on how this works. So here's Jasmine's Key Vault, build 2019. And then I'm going to secrets. And she has created a secret named build secret. I'll click on it, and I'll also add a new secret so we are aware what's happening. And then I'm going to enter a value as build demo key vault build demo key vault, and basically create. OK, now I'm going to make sure that this vault has been granted access to the right applications. Remember dev.win4, Jasmine's dev machine? That is now shown as an identity because it was provisioned by Azure. So I go to access policies, the way you grant any key vault an access, and make sure that dev.win4 has access to this particular key vault. Now, using some of that dark magic again, I'll fast forward time. I'll just commit these changes. And then go to stage 2. OK, over here, Jasmine has now updated her Flask application with another page, Key Vault. In this particular page, what she's basically doing is she's going to get credentials by using the MSI authentication method or MSI authentication class and pass these credentials to a Key Vault manager or a Key Vault client. With the help of Key Vault client, she's going to then basically give her vault details, which is build 2019, and the secret name, build secret, with and to basically retrieve the secret value. OK, so I'm going to run this application locally. All right, so the application is ready. We'll go add a new tab. I go to localhost. OK, so I have a new web page that basically calls the Key Vault URL path. OK, looks like I was able to successfully get the secret at runtime using MSI, the 41. And this is my secret, which was build demo key vault. And also, here's basically us confirming that this is running locally on Jasmine's machine. As we have seen, bringing Key Vault and managed identities together is an extremely powerful combination. This not only helps Jasmine remove end-to-end secrets, but also ensures that all her secrets are only accessed at runtime. Here's the application that we have published to the web app, and when I click on Get Secret, it's able to get, at runtime, the secret value build demo Key Vault. One second. OK, so I clicked on Get Secret. This is basically the web app that got hosted. And when I click on it, it's basically able to retrieve the secret value. When you're developing in the Azure stack, you will inevitably encounter Azure AD, which basically means you need to work and get tokens so that you can talk with other Azure services. While Jasmine was able to give an identity to her machine because it's running on Azure, not every scenario will call for that. You could be having a scenario where you don't have managed identities available at your disposal. Now, in these scenarios, getting those tokens from Azure becomes tricky because you are going to replace a secret with another secret. Now, let's see how we can develop code without Azure managed identities and without secrets. You can use AppAuthentication library. The AppAuthentication library simplifies your developer experience when you do not have Azure managed identities. It implements a class, Azure Service Token Provider. And the way this particular library works is, when you are developing locally, it is going to use your developer context to get that token and give it to the requesting Azure service. So basically, the AppAuthentication library is trying to go to either your Visual Studio developer account or CLI session or integrated Windows authentication and get this token and give it to the Azure AD service so that end-to-end, when you're developing locally, you do not have any secrets. Now, this library also simplifies when you push the code to production. During that time, it seamlessly uses either a service principal secrets, a certificate, or managed identity if one is available without changing any code. So you're able to create and develop an experience where you don't have any secrets in your code. Here's a small code snippet that shows how we are using this class to call Key Vault and give the token that Key Vault needs. Now, if you are using Azure SQL and use Entity Framework, this is news for you. We have updated AppAuthentication library and released 1.2.0 that previews a seamless way for you to use Azure SQL. And the best part is you do not have to make any code changes. While this experience is currently available only in .NET, as part of Unified Authentication Experience, it will be rolled out to other languages, starting with Python. So keep your eye out. OK, so far, we have seen that this credential problem is real. And the fact is that the earlier you catch a secret, the easier it is for you to fix. If your service basically is at a very mature stage and you find a secret, changing the pattern or changing your design will become tricky and hard. So catch them young and kill them. The second thing is regularly check your code for exposed secrets. There are so many secret types that are getting introduced. Right? You have API tokens, you have auth connection strings, multiple things. So you have to exactly know what kind of pattern you're looking for so that you can find them. In your thread model, right, or basically when you're doing an SDL or doing a design of a new service, make sure you give serious thought to how the identity and authentication works. It's very important that you figure it out and make the entire experience as secretless as possible. And finally, it's very important that you have secrets in Key Vault, right? That helps you make sure that you're using it only at runtime, getting these secrets, and not basically persisting anywhere. Implementing all these, Jasmine definitely makes her code more secure, her service more secure. She's amplifying security. But we left out one key piece. If you have an exposed secret that got into the hands of bad actors, they are using it, and you are not even aware. There are no failed detections. There are no brute force attempts. They are able to use your service with perfection, right? That brings a very important aspect. Is Jasmine breach ready? Now I would like to welcome Rich, who is the engineering manager for Key Vault, to help Jasmine solve the last piece of puzzle, that is basically make her breach ready, and also share some very cool new features coming to Key Vault to make you more secure.
Thank you, Krupa. A little bit about keeping secrets safe out of code and into Key Vault and things like that. I'm going to talk a little bit more about secrets from an operational point of view and managing their lifetimes that way. So, and along the way, I'm also going to introduce you and preview some features that we have coming that I think you'll be the first to see. So to start, I want to talk about rotating secrets. So it's important to be able to rotate your secrets quickly for lots of different reasons. The first and most obvious reason is you want to be breach ready. If you discover somebody's gotten into your system, you want to be able to rotate very quickly in order to mitigate that breach. But that's not the only reason you might want to rotate your secrets. If you can rotate for other reasons, maybe you can prevent that breach in the first place. So, for instance, you want to make sure that if secrets have leaked into logs or otherwise been stored someplace where you didn't expect or want them to be, that you can rotate those secrets relatively quickly. Maybe employees are turning over and leaving the company, and they've had elevated access to your secrets. It's a good time to rotate your secrets and ensure that they don't retain that access. Finally, it's just good best practice for all of those reasons and more to just continually keep your secrets fresh and rotate them on a regular basis. So Jasmine's found some credentials in her logs. Did you notice the campfire? That indicates that maybe something went wrong. I really wanted this slide to resonate with you guys, and so I know some of you might not relate to your hair on fire, so I thought campfire. So what Jasmine needs to be able to do immediately is rotate those credentials. But sometimes that might be difficult. A lot of times when we create our applications, we might create our applications and treat secrets as if they were kind of like startup configuration. They're sort of static. Once the application is started, we can't do anything with them after that. So we read our secrets from Key Vault. Then when we need to go rotate our secrets, unfortunately, the app is broken. And the only way to fix that at this point is to redeploy the application or maybe restart it. Now, if you're in a breach situation or you just want to roll quickly, that could be problematic. If you have a really good CI/CD system, I don't know, maybe you can redeploy your apps quickly in an hour or two or something like that, but there's a lot of reasons to believe that that might be difficult to do. And if it is difficult to do, it's going to possibly make you question whether you want to rotate at all. Like if you lost or you discovered you had some secret in some logs, you might be asking yourself, do I really need to roll my secrets? When in fact, you probably just want to roll them. If it was easy, that's what you would do. So I'm going to show you a different pattern that you can use to make this simpler. So what I'm about to show you assumes that you have done some of the stuff that Krupa has talked about, and in particular, you're using managed identities so that you don't have a root credential you need to manage. So you can get to Key Vault without having to worry about that particular credential. And what we're going to start with this time is instead of a single key, we're going to have 2 keys. And we're going to put them both into Key Vault. And when the application starts up, it's going to read both of them from Key Vault. And that gives us a backup, so that when we rotate our key, the application, and we put it into Key Vault, the application's going to find that it fails to get to its resource now, because the key's no longer good, but that's okay. It has a backup. It can fall back, and then it can update and get the most up-to-date version of the new key at its leisure, lazily, in the background if it wants to. So let me show you some code that makes that work. Okay, so this is intended to be Jasmine's back-end order processing system. I've got some constants here, a vault, and I've got an array of secret names. Those are my primary and secondary keys to my store. I've then got a factory class here. The factory class is what I'm going to use to get my table service object to get to my storage. I've got 4 methods in here. There's a constructor. It takes a Key Vault client that I created off stage. It takes the vault URI that's above, and it takes that array of 2 secrets, just the names in there. When I construct this object, I'm going to take those 2 secret names and I'm going to expand them into some other entries that also contain a value. I'm going to set that to none to begin with to indicate that this is a value that needs to be updated and pulled from Key Vault. And I'm going to keep an index of which of these 2 is my current secret. My update secrets method usually will be doing nothing because I should have both secrets pulled, except for the very first time or whenever there's a failover. And so it's just going to go through and find ones that are marked as none and then fill them in if necessary. Get client is where I will construct my table client. It's going to use the most recent value, the one that I'm currently calling my primary, and it's going to construct a table service object and hand it back. Should that table service stop working because it's unauthorized, I'll fail over. And all I'll do is mark the one entry that I'm using currently as my primary as none, indicating that it needs to be filled in again later, and then move my index forward. As I'm processing my orders, I get my table service object. I'm running through and I'm processing those orders, accessing my data store, and at some point, if I decide to rotate my secrets, I'll end up with a 403 from storage. But that's okay. I call failover. I get a new table service from the factory, and I keep going. Let me show you that working real quick. So off to the left here, I have that fantastic, highly scalable order processing system doing its order processing. I have a script that I've written that will rotate the secrets. It's not anything magic. It just uses 2 Azure CLI commands to regenerate keys and then store them back in Key Vault. And there we've rotated the secrets. It sometimes takes storage a little bit to realize that it needs to cut off access. Sometimes it's inconveniently timed for demos. But there we go. We failed over, and we continue working. So if you have things working in that way, then if you discover secrets someplace where they shouldn't be, you don't have to think about it. You can just go to the command line, rotate your secrets, and your app doesn't go down. You don't have to redeploy. You don't have to think very hard about it. And that puts you in a great position with respect to operational security. So next I want to tell you about a new feature that's coming. Key Vault's integrating with Event Grid. So I don't know if you guys know much about Event Grid. It's a fantastic service that allows you to hook your code up to events that are being emitted by other Azure services. It's in our integration. Key Vault's integration is in private preview right now. You can see the QR code. If you go to the site there, you can request access to the private preview. But what this gives you the ability to do with Key Vault is lots of things, actually. You can take action to invalidate secrets that may be expired. You could perhaps monitor your secrets when new ones are being created to ensure that those are appropriately newly created secrets. But probably the most interesting thing is being able to automatically rotate your secrets. So, a lot of times people do this by hand these days, or they do reminders, but with Event Grid integration, you can just set expiry points on your secrets themselves, and you'll get an event that can fire an Azure function or a runbook or a webhook and cause you to run your code that you can use to rotate your secrets. So let me show you that real quick. Actually, hold on. Let's go through this first. So now Jasmine's got 3 campfires. She's got 3 campfires because she set her certificates to expire. And that was a good thing to do, but now it means that she might be at risk of an outage. And so this is actually one reason that people frequently set their certificate expiries to be way off in the future someplace, because they don't want to have 3 campfires on their head. So just real quick, this is how we would use Event Grid in this case. So we've got our Key Vault safely storing our 2 keys. We've got a resource that we need to rotate. Key Vault, or a key is about to expire. So we introduce Event Grid, and we've got an Azure function here. With the Azure function, we can code that up to do the rotation for us. With managed identities, we can give that function that has its own identity through Azure access to both the Key Vault and the storage resource that we have, so that it can manipulate the storage and store the keys back in Key Vault. So then, when Key Vault tells Event Grid that this lifecycle event has happened to the secret, we invoke the function, we rotate the secret, store it back into Key Vault, and given the code that we showed earlier, your app continues to run. And this is, you don't have to think about it, it just happens. If you do this, then you get extra goodness, because rotating secrets rotating secrets often is good practice. The more often, the better, but it's difficult to do that if it's not automated. And if it's not automated and it's difficult to do, then it's hard to make sure that your code continues to work, because any code that you don't run on a regular basis won't run when you want it to. So if you can automate using Event Grid, and you can roll your secrets over frequently, then you know that you're ready in case of a breach or any other thing that causes you to need to roll over quickly. So I'm going to show you for a sec the actual UI that you use to configure Event Grid with your Key Vaults. So if you're in the preview, here's the UI for a vault. In the UI, if you're in the preview, there's an events lightning bolt. If you click onto that, then you get the ability to subscribe to a new event. So we can give it a name, but most importantly, you can pick several event types. So for all of the major types of secrets that Key Vault supports, the 3 ones, certificates, keys, and generic secrets, we will support 3 event types. There's near expiry, expired, and new version. So for instance, for certificates, near expiry is the one that Jasmine needs in this particular case in order to prevent her outage. So if she's set that up, then she can write a simple function like this one here. It's an Azure function that can be triggered by the previous subscription. It receives an Event Grid event, And within that event, she can pull out the ID of the secret that's encountered this near expiry event. And if it's one that she's interested in, she can regenerate the key in storage. She can do this because she's authenticated earlier using the managed identity of the function that has access to that storage account. She can save that secret back to Key Vault, giving it a new expiry so that the next time that this secret gets close to expiring, she'll get another event setting off the same code again. In this case, she's going to make it expire in 90 days from now. And she's set up to just continue this over and over again. So that's Event Grid. I'm excited about that. So the next thing I'm going to show you is another previewed feature that's coming. Key Vault is integrating with Azure Policy as well. If you use the QR code, there's another sign up that you can go if you're interested in trying out the private preview of a policy. Integration with Policy gives you the ability to find your secrets, ensure that they are not going to cause an outage due to expiry, ensure that they are strong enough, enforce validity periods, and more. So in this case, Jasmine's manager wants to ensure that her entire org is doing the right things with their secrets. So we trust that people are doing the right things with secrets in terms of making sure they rotate them often, making sure that they're not in danger of an outage, but we verify. And that's what policy is about, is as an organization, we don't know how many secrets are being created. We don't know for sure whether the right things are happening with them. But with policy, we can discover and enforce things that make sure that those things are happening correctly. So I'm going to show you a little bit of the UI around that, just so you can see that it's working. Here's what we're going to do. So I've got a Key Vault. I've got a resource group. And I've applied a policy to that resource group. And this is the policy that I have applied. In this particular policy, I've said I want all the secrets in my resource group to have at least 60 days before they expire, 60 days from now before they expire. And so once I set that, the policy system has found secrets that are going to expire within those 60 days. I'm in danger of an outage, but now I know, and I can go track down why that is and what's happening. If I look at this particular policy thing here, I can find that there is a secret name, conveniently named component name here, but a secret name, endgame cloud adoption rate, that is in danger of expiring. I can go view that resource. I'm at the Key Vault. I can go find, it turns out it's a certificate that's in here. There we go. So as we can see, endgame cloud adoption rate is going to expire in June, which is far less than 60 days. That means I have about a month to do something about it before my service has a problem. But I discovered that because I was able to set policies, even though I didn't necessarily know those secrets existed. And so that's Key Vault integration with Azure Policy. So during the course of this talk, we've showed you how to keep your secrets out of code by finding them, by eliminating them altogether, if we can, using managed identities. Where we can't eliminate them, we put them in Key Vault. Once they're in Key Vault, we want to make sure they're fresh. We want to automate rotation. We want to make that rotation simple and easy so that when we discover the potential need to rotate them, we don't have to think twice about it. We want to make sure it's automated so that it happens regularly and our secrets have short lifetimes. We've also learned about policy and how we can find secrets that are either insecure or might cause us an outage. And through all of that, hopefully we can all keep from having campfires on our heads. So thank you for joining us. You guys are the hardcore. You've sucked the marrow out of build. We appreciate it. I hope that you guys have found this useful. We'll happily answer questions. We have to pack our stuff up real quick, but then we can meet you at the edge of the stage if you like. And we have 2 other folks that are here that can also help answer questions. Thank you.